back to the channel. Today's video we're talking about clinometers. So you might be asking, what is a clinometer? Well, basically it's a tool that's used to measure the height of objects that you can't reach the top of. For example, like a building or a tree. They're used often in industries like meteorology, forestry, and surveying. And they can be used to measure both inclines and declines. So you can look down a hill and figure out exactly how high you are from the bottom. And in this video I'll show you in just a moment how to make one. But first, I need to tell you about our sponsor, Nord. Getting a phone call. Sorry. Hey, what's up? I was doing the ad read. What do you mean NordVPN pulled out? Can you get Surfshark? What do you mean? Them too? Okay, well Raid does Not even Raid?
Materials. I have one protractor, a straw, and a weight tied to a string. First, tape the straw to the protractor. Tie the weight on a string through the hole in the protractor. And you're on.
To use the clinometer, look at the top of the object you are trying to measure through the straw. Look at what angle the string is at on the protractor. Then measure the distance between you and the object. Finally, measure the distance between your eyes and the ground.
So, here we have a drawing of the measurements we just took. We have Luke's height, the distance between him and the light pole, and you might be wondering, well, Deeson, how do we get the angle 50? Well, as you saw, we had 140 on the protractor as our larger number. What we have to do is subtract 90 from that, which gives us 50. And the reason behind that, there are reasons, but you don't need to worry about that. Hi, Editor Deeson here. You do actually kind of want to know the reason behind this. Basically, you want to know the angle between the midpoint of the protractor, the 90 degrees, and where the string's at, and that's why I have to subtract 90 from it. So, yeah, that's why. I don't know why I didn't explain this in the video, but there it is. So, come over here, and we need to plug these into the equation of tan, the angle you found, equals the opposite side, which is the one not touching the angle, over the adjacent side, which is the non-hypotenuse side touching the angle. In case you don't know how to find the hypotenuse, adjacent, and opposite sides, here's a quick lesson. So if you look in the bottom right corner, you'll see a 90-degree angle. That's that little square in the bottom corner of the triangle. The side not touching that angle is the hypotenuse, and the hypotenuse is also the longest side of the triangle. Now, if you look in the bottom left corner, you'll see the angle that we're using in the equation. Using this, we can figure out the adjacent and opposite sides. The adjacent side is the side touching that angle, that little yellow one with a 0 next to it, that isn't the hypotenuse. And the opposite is the one not touching it at all. So, I hope that cleared things up. And this is correct, but we need to put it in a format that the calculator can understand, which means that we have to get the x by itself. So to do that, we multiply each side by 180 to get the 180 off there, and that gives us tan 50 times 180 equals x. You plug that into a calculator finally, you get the number 214.5 inches, which in feet is 17.8 feet tall. But there's another step that we forgot about. Because that's not the height of the entire flagpole, that's the height of Luke's eyes. So we have to add the 70 inches from that, which will give us 284.5, which then, if you divide that by 12, gives you 23.7 feet. And you're done.